Okay, welcome back to Unit 5, Day 9 practice. This video we're going to go over example 2. So just to recap the steps that we're doing to predict the products of precipitate reactions. First, we break each reactant down into its cation and an anion, and then we switch their partners to form the new products. And then we check and correct the chemical formula of the products by making sure the overall charge is equal to 0. And if we need to, we'll change subscripts. And then if we have a polyatomic, we need more than one polyatomic, we will use parentheses. So in the first example that we did, when we switched the products, the overall charges were 0, so we didn't need to do anything special with that. All right, let's take a look at our second example. So first thing, again, is we're going to break this down into cations and anions. Remember, the cation will be the metal or NH4+, and that's what will be written first. So that's my cation. My anion will be the rest of it, NO3. Now notice that this has more than one atom, so that means that the information for this will be found on the polyatomic ion chart when I look for its charges. All right, the second one is K with potassium, and then we have iodine. Now, I know these are two separate atoms because they both begin with a capital letter, right? So Ki is not one element, they're two separate things because they begin with a capital letter. Okay, so now that I've done that, I'm going to go ahead and switch these to form new partners. So remember, the cation must go with the anion. The cation is always written first, so I'll switch the first and the last. The first and the last will go together, and that will form AgI. And then I'll switch the inner ones. Now the thing with the inner ones is the cation, whatever is written first, has to be written first in the product. So here the NO3 is written second and the K is written first, so the K has to be written first here. Okay, so then I'm going to write K, NO3. So that is my new product. Now I need to just check the charges once again. So to do that, the first thing I'm looking at here is silver Ag. It's a transition metal. Now, for most transition metals, you have to figure them out. But silver is one that it actually has a common charge. So silver has a common charge of +1, and zinc has a common charge of +2. Now, if you didn't know that, how would you figure it out? Well, what you would do is you would go back to the reactant, AgNO3, the reactant that silver came from, and you would figure out its charge from there. So we know that the overall charge of this reactant must equal 0, right? Well, let's figure out what the charge of nitrate is. And then once we know that, we can figure out what the charge of silver must be. So nitrate on my polyatomic ion table has a -1 charge. See, it's a -1 charge. So this is -1. So I'm asking myself, well, what can I add to -1 to give me a 0? And that answer will be +1. And so that means that silver has a +1 charge. Okay? Now remember, doing this to figure out if this is the correct formula. So for iodine, I go over to, that's my nonmetal, I go over to my nonmetal side, and here's iodine. It's in group 17. It has a -1 charge. So there we go. So this is also looking good. This works out because I know this is the correct formula because when I add the +1 and the -1 together, it'll give me an overall charge of 0, so that's good. We're going to do the same thing with the potassium nitrate, KNO3. So potassium is a group 1 metal. That means that it has a common charge. It's not a transition metal. And group 1 metals have a +1 charge. So I know that potassium has a +1 charge. And then we already looked up nitrate in our table here. It has a -1 charge. So that means that both of these, once again, I've lucked out in both cases. Example 1 and example 2, I haven't really had to do anything. This is the right charge, okay? Let's look at this second, we'll take a look at this third example in the next video, and then we'll see if our luck will run out.